Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving systems of linear inequalities in two variables. Let's start with a couple of definitions. A system of linear inequalities in two variables consists of at least two linear inequalities that are graphed on the same coordinate plane. The solution of the system of inequalities is the set of all ordered pairs that make the system true. Solving system of inequalities involves finding the region on a graph where the solution sets of two or more inequalities overlap. So in the system of inequalities that's shown here, the overlapping region is right in here, and this is where all the solutions to the system of inequalities lie. So in example 1, it says each graph below represents a system of linear inequalities. Write the two inequalities which make up the system, and then determine if the given point is a solution. So in problem A, they've given us a system of inequalities, and they want us to write a system that represents the inequalities shown in this graph. So what I'm going to do to make this easier is I'm going to label one of these lines line 1 and one of these lines line 2. It doesn't matter which one you start with, so I'll just make the dash line number 1 and the solid line number 2, okay? So I'll start with line 1. If I want to write a system here, I need to know the slope, the y-intercept, and which symbol should be used. Okay, so to get the slope, I'll pick two friendly points on that dash line. How about the y-intercept and the x-intercept? So starting with that bottom point, the x-intercept, I'm going up 1 and left 1, so that would be -1. If I reduce that, I get a slope of -1. Now, the y-intercept, the b, it touches the y-axis at +1. So I know the b is equal to +1. Now for the symbol, we need to look at where it's shaded. Notice that it's shaded below the line. So that's less than. Now do not put a solid line under that because it's graphed with a dashed line. So when I go to write my inequality, it would be y is less than -x plus 1. That's the first inequality in your system. All right, now I'll do the same thing for line 2, which is our solid line. I want the m, the b, and the symbol. So let's pick two friendly points on the solid line. Again, I'll use the y-intercept and the x-intercept. So I'm going up 2 and right 2, so 2 over +2, which reduces to 1. The y-intercept, it touches the y-axis at -2. Now for the symbol, let's talk about where it's shaded. It's shaded above the solid line. It's shaded above the solid line. So I know I need to use greater than, and because it's solid, I need an equal symbol. So my second inequality would be y greater than or equal to 1x minus 2. Now, they want to know, is 0, -1, a solution to this system? And they want us to verify both graphically and algebraically. So I'll verify algebraically first. Now, here's what it means to verify algebraically. I'm going to write down both my inequalities. Y is less than -x plus 1. And over here, I'll write down y is greater than or equal to x minus 2. Then I'm going to take this ordered pair. I'll put an x above the 0 and a y above the -1. And I'm going to plug those values in to each inequality and determine if it makes the inequality true or false. For it to be a solution, it must make both inequalities true. So for the y, I'll plug in a -1. For the x, I'll plug in a 0. So -1 is less than +1. Is that true? Yes. A negative will always be less than a positive. All right, now I'll do the same thing for my second inequality. I'll plug in a -1 for the y. I'll plug in a 0 for the x. So here we're asking, is -1 greater than or equal to -2? That is also true. So yes, it is a solution. We proved it or we verified it algebraically. Now, to verify it graphically, what you do is you plot a point at 0, -1, and notice it's in the common shaded area. So we have verified graphically also. All right. Problem B. We have two inequalities shown on this graph, and they're both dashed lines. So it doesn't matter which one you make number 1 and which one you make number 2. So I'll make the one with the negative slope, I'll make that line 1, and I'll make the one with positive slope, I'll make that line 2. So let's start with number 1. Remember, well, all we need is the M, the B, and the symbol. All right, so if I'm starting with line 1, this is the negative slope one. I need 2 friendly points. So I can use this one and this one. All right, starting at the bottom, I'm going up 1 and left 2. Up 1 and left 2. So that'd be 1 over -2. So my slope is -1/2. The B is -1. That's the y-intercept. Now the symbol. To get the symbol, you ask, where is this inequality shaded? Notice it's shaded above the line. So for above, we use greater than. All right, now for line number 2, this is the line with positive slope. I will pick 2 friendly points. I'll use the y-intercept of 3 and the x-intercept of -3. So if I start at the bottom, I'm going up 3 and right 3. So up 3 and right 3. 3 over 3 equals +1. The B is 3 and the symbol. So to get the symbol, I want to see how it's shaded. Notice it's shaded below the line. So for below the line, we use less than. All right, now let's write our system. Let's start with line 1. Y is greater than -1/2 x minus 1. For inequality 2, y is less than x plus 3. All right, our question is 1, 4 a solution to the system? Verify algebraically and graphically. So to verify algebraically, I write both inequalities down. Y is greater than -1/2 x minus 1, and y is less than x plus 3. And above the 1, 4, I'll put an x here and a y here. I'm going to plug in a 4 for the y. 1 minus 1. So 4 is greater than -1/2 times 1 is -1/2 minus 1. So is 4 greater than negative? If I combine those, I get -1 point. I'll just write it as a decimal. Yes, that is true. 4 is greater than -1.5. So this one is true. All right, now I'll plug into my second equality. I'll put a 4 for the y, less than, I'll put a 1 for the x. So this is 4. Is 4 less than 4? So that's false. Because I got, to be a solution, you have to get true on both of them. So this one is no, it is not a solution. I'll just abbreviate that. Not a solution. Now to show graphically, I'm going to come back here. Let me erase my shading so you can see better. I'm going to plot the point 1, 4. And what I want you to notice is it's on the line with positive slope, but the line is dashed. So that is why this point is not a solution to this inequality. All right. Example 2, solve the system of inequalities by graphing. And our two inequalities are x is greater than 2 and y is less than or equal to 4. Now, I want you to go back up to our definitions where we started. where it says what is solving. Solving systems of inequalities involves finding the region on a graph where the solution sets overlap. So that's what we're going to be doing here. We're going to be finding where the solution sets overlap. So if I were to graph x is greater than 2, remember if we only have an x, this is learned from previous lessons, this is going to be a vertical line and it's going to be dashed. So I'm going to go to, here's my x-axis, and it's going through x equals 2, and I want it to be vertical and dashed. Now, what I've done now is I've broken this coordinate plane up into 3 regions. Everything to the left of that line, everything on that line, and everything to the right of that line. But we want to shade the area that is greater than 2. So the area of this graph that's greater than 2 would be to the right. So that is the shading for the first inequality. All right, now our second inequality. Our second equality is going to be a horizontal line because it only has a y. Horizontal line. But it's going to be solid because there's a solid line under the symbol. So I want to go on my y-axis to y equals 4. 1, 2, 3, 4. And I want to draw a solid line. So there's my solid line. Now we need to figure out where to shade. Our symbol is less than. So I want to shade all the y values that are less than or smaller than that line. So let me pick a different color here to shade. So I'll shade that in yellow. So less than would be everything below that line. Now what you're going to do is you're going to look and say, where did the green and the yellow overlap? Where the green and yellow overlapped, that is your solution set to the inequalities. I'm going to shade it in a different color so that we can see it. Now, I also like to put, I also like to put a big S to indicate this is the solution set of my inequality. So our first question says, is 5, 0 a solution to the system? Verify graphically. So to verify graphically, I'm going to plot the point 50. 1, 2, 3, 4, 5. 50 would be right here, and it is in the common overlapped area. It's in the solution set, so we will say yes, it is a solution to the system. All right, example 3. Solve the system below by graphing. So what we're going to do here is they've given us 2 inequalities. We're going to graph the first inequality and shade it. Then we'll graph the second inequality and shade it. And then we'll find the overlapping region. So for our first inequality, we have a slope of 2/1 and a y-intercept of 3. And it's going to be a solid line. For our second inequality, we have a slope of 1/(-1), and we have a y-intercept of 4, and it's also going to be a solid line. So let's graph our first inequality first. It begins at y equals 3, 1, 2, 1, 2, 3. We have a slope of 2/1, so up 2/1. And we can go the opposite way, down 2 and left 1, down 2 and left 1, down 2 and left 1. I like to fill up the whole grid. And then I'm going to make that as straight as I can into a solid line. Okay, after you get your solid line graphed, now you're going to decide where to shade. So our symbol here is less than. So that means I want to shade below this line. everything below this line because the symbol was less than. All right, so there's our first inequality. All right, our second inequality starts at 4. So 1, 2, 3, 4. Whoops, change to a pen here. And it has a slope of -1. So down 1 over 1, down 1 over 1. And I'll just keep that going. Okay, and I'll try to make that line as straight as possible. All right, now I have to decide where to shade. It is also less than. So let me grab a different color here. So I'm going to shade everything below that second line. Okay. Now after you shade that inequality, now you're going to find the region of the graph where the overlap is. All right. And hopefully you can see that our overlapping region is right in this area. So this question says, is 2, 1 a solution to the system? Justify your answer algebraically and graphically. So to justify it algebraically, I'll have to write down both inequalities. And then label this as xy. So I'll be putting a 1 for the y. I'll be putting a 2 for the x. And I'm determining if this is true or false. So 1 is less than or equal to, 2 times 2 is 4, 4 plus 3 is 7. So is 1 less than or equal to 7? All right, it's true in that equality. Now same thing over here. I'll put a 1 for the y. I'll put a 2 for the x. So is 1 less than or equal to? -2 plus 4 is 2. And that is also true. So algebraically, we're saying yes, it is a solution. Now let's graph that point, 2, 1. And notice, yes, it is indeed in the shaded area. So yes, it is a solution. All right, example 4. Solve the system by graphing. We have 2y plus x is less than 8, and 3x minus y is less than 4. So on this problem, before we can graph our inequalities, we're going to have to get the y by itself. In other words, we're going to need to rewrite it in slope-intercept form. So I'll subtract x from both sides. So 2y is less than -x plus 8, and then I'll divide everything by 2. Whoops, I didn't need to put less than or equal to. It's just less than. So this is supposed to be just less than. All right, -1x divided by 2 would be -1/2 x. And 8 divided by 2 would be +4. So let's graph that. We'll start at 4. 1, 2, 3, 4. We'll go down 1 over 2, down 1 over 2, down 1 over 2. And then I can go the opposite way, up 1 and left 2. And I want to connect these points with a dash line this time. So dash, 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 dash. And I want to shade it. So for less than, we're going to shade that line below. So everything below is a solution to that particular inequality. All right. In other words, most of the coordinate plane here is a solution to that inequality. Now let's solve our second inequality. We want to put it in slope-intercept form. So I'll start by subtracting 3x. So -y is less than -3x, because we're subtracting it, plus 4. Now we're going to divide everything by -1. But remember, when you divide by a negative, you must reverse the symbol. So this would now become y is greater than. -3 divided by -1 is +3x. And 4 divided by -1 is -4. So this inequality starts at -4, 1, 2, 3, 4, and goes up 3 over 1, up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, and it's also a dashed line. It's hard to keep these dashed lines straight as I want them to, but I think you get the general idea here. Now, for this line, our symbol is greater than. So let me change colors here of my shading. Greater than means I'm going to shade everything above this line. So everything above that line. Now once they're both shaded, you're going to determine the region of overlap, which hopefully you can see is this region right in here. So I'm going to put a big S for solution. Now they want to know, is 2, 2 a solution? So I'm going to write down my 2 inequalities. And then I will substitute in the point that I was given. So I'll put a 2 for the y. And evaluate that. So this would be 2 is less than negative 1/2 times 2 is negative 1, and negative 1 plus 4 is 3. So is 2 less than 3? That is true. All right, over here, put a 2 for the y, a 2 for the x. So is 2 greater than, 3 times 2 is 6, 6 minus 4 is 2. Is 2 greater than true? That's false. Now, with our graphically, the point 2, 2, 1, 2, 1 falls right here, and it falls on a dashed line. So this is not a solution, and I'll just abbreviate solution. 2, 2 is not a solution to the inequality. All right. Example 5, solve the system by graphing. Now what I'd like you to do is pause the video and try this problem on your own. All right, welcome back. Let's see how you did. I took my first inequality and I put it in slope-intercept form. So I subtracted 2x from both sides. So that gives me y is greater than or equal to negative 2x plus 4. So I'm starting at 4, 2, 3, 4. I'm going down 2, right 1, down 2, right 1, down 2, right 1. And this should be a solid line. All right, then we shade it. For greater than or equal to, we shade above the line. So let's shade above our line. All right. Now I'll take our second inequality, 3x minus y is less than or equal to 6. So I'll start off by subtracting 3x, which would give me negative 3x plus 6. And then I have to divide by negative 1. Remember, when we divide by negative 1, we must reverse the symbol. So this would become greater than or equal to. Negative 3 divided by negative 1 is positive 3x. 6 divided by negative 1 is negative 6. So this line starts 1, 2, 3, 4, 5 at negative 6 and goes up 3 over 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And it is also a solid line. So there's our second inequality. Now for shade it, we want to shade above the line. So let me change colors here. Above the line would be everything here. And so our solution is our overlapped region. And in this problem, this would be our shaded solution set. And that concludes today's lesson, solving systems of linear inequalities in 2 variables.